Hello everyone and welcome to MacTech 40, and today is the video number 7 of our DRDO mains question paper solution. Those who have not seen the earlier 6 videos, just click on the I button in the top right corner and you will find a playlist of the previously uploaded 6 videos. So today we are going to solve question number 3A of paper number 1 of 2019 DRDO mains paper, and this question is of IC engine. The question is an air standard diesel cycle. So here I have drawn the PV diagram of diesel cycle. The pressure and temperature at the beginning of the compression stroke. So that means here first of all we have to write given data. So the pressure at the initially pressure is P1 is equal to 1.03 bar and temperature T1 is equal to 300 Kelvin. The maximum pressure of the cycle, that is here it is the P2 is equal to P3 because constant pressure heat addition is take place in diesel cycle. So maximum pressure, that is in the cycle, that is P2 is equal to P3, that is 47 bar. Now heat is added, heat is supplied is 545 kilojoule per kg. So heat addition, that is Q223, that is 545 kilojoule per kg. So heat transfer take place in constant pressure heat addition from 2 to 3. Calculate the compression ratio. So we have to find first, what you have to find first is compression ratio, RC I am denoting with. Second thing, we have to find the maximum temperature of the cycle. That means T3 here at point 3 the temperature is maximum, so we have to find that maximum temperature. And the third thing is thermal efficiency of the cycle. So thermal efficiency T, and some values are given. Cp is 1.005 kilojoule per kg Kelvin and gamma value is 1.4, it is given. Now first of all we know the compression takes place from 1 to 2. Here it is 1 to 2 compression is there. So compression ratio we can write is as a V1 by V2, and it is as it is a adiabatic process 1 to 2, so we can write P2 by P1 upon 1 upon gamma, because we know PV power gamma is equal to constant for adiabatic process. So P2 is what, 47 divided by 1.03 initial pressure divided by 1 divided by 1.4. So when you solve this you will get compression ratio is 15.32. So in exam if you want to check by yourself that whether your answer is correct or not, so you have to remember some things, that the compression ratio value for a diesel engine is generally 15 to 20, so it is 15.32, so your answer is correct. Next is the maximum temperature of the cycle. Here first thing that we have find out the maximum temperature T3. So for that we have one given data, that is heat supply, that is Cp T3 minus T2. For diesel cycle it is given by Cp T3 minus T2 heat addition at constant pressure. So Q is equal to Cp T3 minus T2, but we don't have T3 or we don't have T2, we have only Cp and Q. So mark is at as the equation number 1. So mark is at equation 1. Now how can we find T2? We know that 1 to 2 is a adiabatic process, so T2 by T1 is equal to P2 by P1 power gamma minus 1 upon gamma. So P2 is 47 divided by 1.03 to the power 0.4 divided by 1.4. So this value comes out to be, and we have T1 value, that is 300 Kelvin. So T2 will be what? So T2 will be 893.71 Kelvin. That is a T2 value. So put this value in equation number 1. You will get heat supply, it is given, that is 545 kilojoule per kg. Cp is what, 1.005 T3 minus T2. T2 is what, 893.71. So when you solve this you will get T3 as a 1436 Kelvin. So this is our second answer. Now third thing, we have to find the thermal efficiency. So thermal efficiency of a diesel cycle, it is given by 1 minus 1 upon compression ratio power gamma minus 1 into cutoff ratio. Here cutoff ratio I am denoting with rho to the power gamma minus 1 divided by gamma into rho minus 1. But we don't have the cutoff ratio, so we have to give it as a equation number 2. Now cutoff ratio is what? From the figure we can say that cutoff ratio is V3 by V2, at which cutoff it takes place. So cutoff ratio is V3 by V2, but we don't have value of V1 or V2 or V3 either. We don't have any values. So what we have to do is, we know 2 to 3 is a constant pressure process. So V2 by T2 is equal to V3 by T3. We have T3 and T2 value. So V3 by V2 is equal to T3 by T2. So it is, when you, we have put the value V3 by V2, T3 is what? It is 1436 and T2 value, that is 893.71. So when you solve this, you will get, and V3 by V2, as we know, cutoff ratio, so cutoff ratio will be 1.60. So put this value in equation number 2 here. Now, so thermal efficiency is equal to 1 minus 1 upon 15.32 to the power 0.4 and 1.6, that is cutoff ratio, to the power 1.4 minus 1 divided by gamma is 1.4 and cutoff ratio 1.6 minus 1. We have all the values now. Put that value and you will get as a efficiency 62.8%. That is a thermal efficiency, and this is the answer, and this is the way you can solve this question. I hope you like this solution, and the way I am written, the same way you have to write in the mains examination. And I hope, and this is a 20 marks question. It is a very good question and easiest question, we can say that. So you can get easily 20 marks. So this is all about today's video. So if you like this solution, then like this video, share with your friends, those who are preparing for these exams, and subscribe our channel to increase our the community, and share with your friends this channel. And thank you for watching this video. Tomorrow we will see some new question of this same series, DRDO mains, and we have another series that is continuing. So I'm writing somewhere here, that is our DRDO mains, engineering service mains, civil service mains, and forest service mains. So these 4 series we are running right now. So we will solve the question from any of these exam, because all these exams have, the mechanical engineering has the same syllabus, the level of question is the same. So anything that we'll do, that will be practice for us. So this is all about information today that I'm going to share with you. So thank you for watching this video.